Hello students, welcome to my channel Positva. This channel is undoubtedly dedicated for physics, especially for those students who are the aspirants in future would be the aspirants of IIT, JEE and NEET. Dear students, in my last video I have discussed with you about the relative velocity. Even today is a relative velocity. In last video I have discussed about the riverboat problem. Today's my topic is to discuss about Riemann problem and airplane wind problem. When we talk about riverboat problem or Riemann problem or airplane wind problem, it means we are talking about the two-dimensional relative velocity in two dimension. Dear student, the problems I'm considering, this is a part of S.C. Verma sir. Okay, one of my favorite book, and as usually it's to all teachers it works. This book is a favorite to all students and teachers. Dear students, some problem I'm considering. A problem is, this is today's topic is a Riemann problem, and then some problem I'll discuss. And after that, I'll discuss about the airplane wind problem. Actually, so many problems I cannot discuss in a video because video becomes large and then it becomes boring. So, I'll try my best to collect this problem in a single video, right? Now, a problem is a man is standing and raindrop is falling vertically. A man is standing and to protect the raindrop, to protect him from rain, he keeps his umbrella at 30 degrees from vertical. Now he begin to walk with velocity 10 km per hour. 10 km per hour. Raindrops hit him vertically. Find velocity of man with respect to road and rain too. This is question in short I have written that when a man is standing, in order to protect himself from the rain, he has to keep his umbrella at 30 degrees, and after that he begin to walk with a velocity 10 km per hour. Now raindrop hits him vertically. Find out the velocity of rain with respect to man and velocity of rain with respect to road or ground. This is the question we have to discuss. Dear student, first if you are a student of physics, this is my own opinion that you should have a good concept. If you have a concept, then anyhow, any method you apply, no matters, you will solve the problem, right? Dear student, for me, if you solve many questions with the wrong idea, then it is not going to work. If you solve a single question with the right idea, it will work in other questions too. Dear student, question is that a man is standing and to protect himself from the rain, he has to keep his umbrella at 30 degrees from the vertical. Now he begin to move with the velocity 10 km per hour. Raindrops hit him vertically. Find out the velocity of rain. Velocity of rain with respect to road and with respect to man, right? Now I'm erasing this and let's add the solution. First case, he is standing, right? This is the case 1. He is standing and he has to keep his umbrella at 30 degrees from the vertical. This is his umbrella, right? So this angle is 30 degrees. This is the velocity of rain with respect to road or ground, you can say, right? Because man is standing, means man is behaving like a ground. So raindrops are hitting him at a 30 degrees from the vertical. So it is the velocity of rain with respect to road, right? In the second case, what happens? Man begin to travel with the velocity 10 km per hour and raindrop hits him vertically, right? So it is a velocity of rain with respect to man. And in this case, it was the velocity, from the case first I am considering, velocity of rain with respect to road or ground, that is making an angle 30 degrees. Solution, the first kind of solution, that is I am following from, I am completely following SCB sir, SC Verma sir, how he solves the problem. He says, velocity of rain, you know, a very basic thing I would like to tell you, you know, velocity of A is A with respect to B is equal to VA minus VB. In my first video, I have discussed with you all that when we talk about the velocity of A with respect to B, that is equal to VA minus VB. It means velocity of A with respect to B means what is the velocity of A when B is at rest? Velocity of A with respect to B means B is the observer. What velocity of A is observed by B when B is at rest? When in many questions in riverboat problem, it is used to say that the problem is given in such a way that a man can swim in still water. A man can swim in still water with velocity 10 km per hour. Man can swim in still water. It means it is a velocity of man with respect to water or river. Now, dear students, VAB you may write like VA minus VB. You know, motion is not absolute quantity. Motion should be defined with respect to any frame of reference. Now you say VAB is equal to VA minus VB. Velocity of A with respect to B means velocity of A observed by observer B when he is at rest. That is equal to VA minus VB. Dear student, VA minus VB, velocity of A minus velocity of B. Now, velocity of A with respect to which observer, or velocity of B with respect to which observer. When you say that motion is not absolute quantity, it should be defined with respect to an observer. Now, you can write any common observer with respect to A and B. What I am saying, VA minus VB, velocity of A minus velocity of B, it is not given that who is the observer. So, for our convenience, I have consider that let ground is our observer, that is VAG minus VBG, and you can write VAG is equal to VAB plus VBG, right? So velocity of A with respect to ground is equal to velocity of A with respect to B plus velocity of B with respect to G, ground. In the similar way here, why I am discussing these all, that this case can be solved like this. You can write velocity of rain with respect to road is equal to velocity of A with respect to ground is equal to velocity of A with respect, that is velocity of rain with respect to man plus velocity of man with respect to road. You can write like this. Or for convenience, in short form, what I am writing, velocity of rain with respect to road or ground, that is equal to velocity of rain with respect to man plus velocity of man with respect to ground. I am writing like this. Now, dear students, in this case, taking horizontal component, right? Taking horizontal component of this. Now, if you take horizontal component, it becomes taking horizontal component of all, right? Considering horizontal component. You know, if you apply, you have to apply on the three components, same thing that we are considering the horizontal component, right? So, horizontal component will be what? Now, horizontal component of this, you know, if it is a r, this angle is theta, then component adjacent to angle is a cos component and component away from the angle is a sine component, right? In similar way, this is away from the angle, so it is a sine component. It becomes, look here, I am writing here VRG, that is sine 30. Now look here, dear students, it is a vertical component itself. So it has a horizontal component 0, or for your convenience you can write like this, VRM cos 90, and cos 90 is 0. And then it comes V man rod. It is horizontal component itself. So you can write 10. So VRG 1 into 1 by 2, that is equal to 10, or VRG becomes 20 kilometer per hour. So velocity of rain with respect to ground works out to be 20 kilometer per hour. Now dear students, considering vertical component, how will it be? Vertical component consider. Then if you can, I'm sure that you can watch. Yes, it's working. Now look here, if you take vertical component of this, then it is the component you are considering adjacent to angle, so it is a cos component. It becomes VRG cos 30. Itself is a vertical component, so VRM, this is, and it is horizontal, so has the vertical component 0, right? It is the horizontal, so has the vertical component 0. So it is 0. So VRG we have find out. So VRM is equal to, VRG is a 20 cos 30, and that is equal to 20. Cos 30 is a what? Root 3 by 2, that is 10 root 3. Dear students, velocity of rain with respect to man is a 10 root 3 kilometer per hour. And the velocity of rain with respect to ground is a 20 kilometer per hour. We solved that. There is another method you can apply. Let's apply another method. Another method is what? Dear students, what I am saying, what I am supposing, let velocity of rain is equal to AI cap plus BJ cap. I am considering that velocity of rain is equal to AI cap plus BJ cap, right? Now, dear student, when the man is standing, the raindrops are falling at 30 degree from vertical. Let the magnitude of velocity is V, right? Then you can write this component will be V cos 30 and this component will be V sin 30. So you can write VR means that is a VR is equal to, you can write this is a V sin 30 I cap, and this will be negative minus V cos 30 J cap. Sin 30 is a 1 by 2, that minus this is a root 3 by 2 V root 3 by 2 J cap, right? This is your equation 1. Now dear student, when the man begin to walk with the velocity 10 km per hour, the raindrop hits him vertically. Now let's find out velocity of rain with respect to man is equal to VR minus VM. VR is AI cap plus BJ cap. Dear student, minus Vm is a 10 I cap moving along x-axis with velocity 10. Then it will be Vrm is equal to, look here, a I cap minus 10 I cap, that will be I cap will be common, that is a minus 10 I cap plus bj cap. Look here, dear student, we have find out Vrm. Now question is saying that when the man begin to walk with the velocity 10 km per hour, raindrops hit him vertically. Raindrops are vertical, means x component is 0, a minus 10 is equal to, dear student, a minus 10 equals to 0 or a is equal to 10. Now you have find out the value of a. Vr is equal to ai cap plus bj cap. If you write here, Vr is equal to, look here, A is equal to V sine 30 and A is 10, that is V 1 by 2, V is equal to 20, right? You have find out the value of V equals to 20. Now look here, dear student, you find out the value of V, that is equal to 20. So velocity of Vr is equal to, that is a is a 10 I cap minus V is a 20, you have find out. So it is a 20 cos 30 or 10 I cap minus 20 cos 30 is a root 3 by 2 j cap, that is 10 I cap minus 10 root 3 j cap. Now you can find out the magnitude of velocity of rain. That is, velocity of rain means velocity of rain with respect to ground we are talking. Now magnitude, you know, 10 square plus minus 10 root 3 square. So it will be 100, this is with 300, 400, root 400 is 20 km per hour. Now dear students, interesting, we have to find out the Vrm. Vrm, velocity of rain with respect to man, it is hitting vertically, that is bj cap. This is only bj cap, means this one is a, or minus 10 root 3 j cap. So velocity of rain with respect to man, if you take magnitude of it, that is equal to 10 root 3. That we have got in the from that last method, in first method. This is the two method. Why I am discussing with different methods? Because it will improve the idea, the concept in you. It will inculcate the concepts of physics in you if you used to solve the problem with different methods. Let's talk another question. Another question is, dear students, the second one is a very important, and many times such a questions has been asked in JEE. Second question is, question says that a man moves with 8 km per hour, right? A man is moving with 8 km per hour and raindrops are hitting him at some angle. The man is speeded up. It's a speed, he increases up to 12 km per hour, then raindrop begin to hit at 30 degrees from the vertical. Now, find out the velocity, the direction of rain and its velocity. When it says the direction of rain, it's a velocity of rain. If nothing is given, it means it is talking about the velocity of rain with respect to ground. Right? Dear students, question is just a bit I'm missing. So this is also from SCV. So I might take help of my mobile. What is the real question? I do not know actually. Or no. Problem is, a man walking with velocity 8 km per hour, rain hits vertically. I'm writing in very short to the question. Now he speeded up to 12 km per hour. Drops, makes an angle 30 degree from vertical. Find the direction and speed of rain. Dear student, this is the question. That question says, a man walking with a speed 8 km per hour, raindrops hit him vertically, right? Now he speeded up to 12 km per hour. The raindrops hit at making an angle 30 degree from the vertical. Find the direction and speed of the man. Dear student, I'm erasing the question and now let's talk about the solution. Let's talk about the solution. In last question, it was similar to this question. I have discussed the solution with two methods, right? The same I'll try my best. One method I'll discuss and second would be the homework for you, right? If you can solve the problem from the second method, then undoubtedly you know the physics. Dear students, the first case is the man is moving with velocity 8 km per hour. Raindrops hit him vertically. It means it is the velocity of rain with respect to man. And when the man is standing, suppose the raindrops are making an angle alpha from the vertical, so it is alpha. If the man is standing, it means it is the velocity of rain with respect to ground. Dear student, in the second case, what happens? The velocity of man is speeded up to the 12 km per hour, and now this is the velocity of rain. Now the rain hits at 30 degree from the vertical. This is 30 degree from the vertical. This one is a 30 degree. It is the velocity of rain with respect to man. And when the man is standing, it is a velocity of, take like this, it is the velocity of rain with respect to ground, which is making an angle alpha. Dear student, don't be confused what I'm talking. In case 1 and case 2, both velocity of rain with respect to ground, I have taken that at an angle alpha from the vertical. Dear student, yet despite in the first case the man was moving with the velocity 8 km per hour, whereas in second case man is moving ahead with the velocity 12 km per hour. Despite in both the cases we have depicted that velocity of rain with respect to ground is making an angle alpha from the vertical. Actually, when it is alpha, so it is a vertically opposite angle would be the alpha. Dear student, because velocity of rain with respect to ground is what? Our velocity of rain when man is standing. That is means when man is standing, that is velocity of rain with respect to ground. It is not going to change whether the man is moving with velocity 8, 10, 12 or 15. There is no matter, because velocity of rain with respect to ground, that is ground is at rest and the rain is falling. In both the cases, behavior of ground is similar. That is why VRG in both the cases has been depicted by the same figure. Now, dear students, what we have to find out, the direction of rain, right? Direction of rain means what actually in which direction rain is falling. It means when man is standing. That is, you can say whether man is standing or moving, no matters at what angle actually the rain is incident falling on the ground, right? That is we have to find out. Dear student, again I am writing velocity of rain with respect to ground. You can write that velocity of rain with respect to man plus velocity of man with respect to ground. Same idea I am following. What is that? Velocity of rain with respect to ground is equal to velocity of rain with respect to man plus velocity of man with respect to ground. Now, dear students, taking horizontal component in this, in case 1, considering horizontal component, what will be this is the velocity of rain with respect to ground. It's a horizontal component, that is VRG. Now you are talking this component of this velocity, that is away from the angle, so it is a VRG sine alpha. That is equal to VRM, it is a vertical, so has the horizontal component 0. VMG is this velocity of man with respect to ground is a 8. That is equation 1. Now, dear student, let's talk about the second case. Dear student, for the simplicity, very truly I am telling you that this question I have considered, I have taken from S.C. Verma sir book, right? SCB for part first. To solve this problem, what we are going to do, that is take a perpendicular on this. It will make the problem very easy. I am taking perpendicular on this line, right? Let it is O, this is A. Dear student, look here. This whole angle is 90 degree. This is 30 degree. So it is a 120 degree. Now, interesting. This whole is a 90 degree. So this one is a 30 degree. Complete angle from here to here is 120. This one is 30 and this is 90. So 90 plus 30, 120. Now in this case, this one, we have constructed this line for the convenient, for make you convenient to solve the problem. So this one is a 90, so it is a 30 degree. Now dear student, considering all these components along OA, considering component of all these terms along OA, considering now let's talk along OA. VRG is what? This, right? Is a component along OA, right? Now dear student, this angle is alpha, this whole angle is a 30 plus alpha. Look here, this is 30, this is alpha, so it is a 30 plus alpha. Now these two are rectangular component, perpendicular component. Now you have to take velocity of RG along this, means angle is this 30 plus alpha away from the angle, so it is a sine component. Component adjacent to angle is a cos, and component away from the angle, component of VRG along OA is away from the angle. This angle is 30 plus a. These two are the rectangular components. So along OA, this component is going to be VRG sine 30 plus alpha. Now look here. This is VRM. Component of VRM along OA. Now, it will be cos 90, VRM cos 90, and that will be 0. Again, I am repeating, this is component of VRM along OA. OA is 90 degree. So, component of VRM that is adjacent to angle VRM cos 90 would be 0. So, this term vanishes. Now, VMG that is 12 km per hour and its component along this that is 12 cos 30. The component of 12 km per hour adjacent to angle. So, it is a 12 cos 30. Now, dear student, this is the equation to divide these two. Now, no problem, we can solve very easily. I am removing this all, there's no need right now. Divide these two, you will get sine 30 plus alpha divided by sine alpha is equal to 12 cos 30 upon 8. So it is a sine 30 cos alpha plus cos 30 sine alpha divided by sine alpha, that is equal to 4 2 is 3 is 3 by 2 cos 30 is a root 3 by 2. Now dear students, let's talk. This is sine alpha, this is cos alpha upon sine alpha. I am separating this. Sine 30 is a 1 by 2. This is cot alpha, right? Now, dear student, sine alpha would be cancelled. This is root 3 by 2. Cos 30 is a root 3 by 2. That is equal to 3 root 3. Sometimes a problem. 2 I am cancelling from denominator. So, cot alpha equals to 3 root 3 minus root 3. That is cot alpha equals to, again look here. Oh my God. This is cos 30 is a root 3 by 2. 4 3 is 4 2 is. So, look here. Please. 2 cancel. 1 2 would be left here. Yet 2 2 is 4. 1 2 would be left here. Now look here. Cot alpha equals to 3 root 3 by 2 minus root 3. If you take root 3 out, that is 3 by 2 minus 1, that is 1 by 2. So it is a root 3 by 2, or alpha equals to cot inverse root 3 by 2. Now dear students, you find out cot alpha. Oh, I have removed. Now, what you have to do? You find out cot alpha. The first equation I think was, I'm missing a bit. First equation was VRG sine alpha is equal to A. Now, what we have to do? We have to find out the velocity of rain actually. The first equation was this, I'm very sure. VRG sine alpha is equal to, that is VRG sine alpha equals to 8. Now you have find out the value of cot alpha. Cot alpha is a what? Look here, this is alpha. Cot alpha equal to, cot is equal to what is? Base upon perpendicular. This is root 3, this is 2. So it is going to be root 3 plus 4, that is 7. So sine alpha will be what? Sine alpha is equal to perpendicular upon hypo, that is 2 upon root 7. So VRG into 2 upon root 7, that is equals to 8, or VRG equals to 4 root 7. That is velocity of rain with respect to ground will be VRG, that is equal to 4 root 7. This is the first method I have discussed with problem. I am very sure, dear student, you should solve from the second method that I have applied in preceding question, and I'm very sure if you can do, then it will make you happy at least. Okay, so let's start next question. Next question is a very simple. Dear student, this question, the source of this question I do not know. Actually, I have seen it in a book. The problem is that a plane, it is a airplane, plane wind problem. A plane has to travel from A to B 5 kilometer, 500 kilometer, 500 kilometer, 30-degree due east of north. Wind is blowing at 20 meter per second due north. The plane can steer with velocity 150 meter per second in air. Find time taken in traveling from A to B. This is the question. Dear student, let's talk about the question. Question is that a plane has to travel from A to B 500 km, 30-degree due east of north. Wind is blowing at 20 meter per second due north. The plane can steer with the velocity 150 meter per second in air. Find the time taken in traveling from A to B. Now, as usual, I am erasing the question and let's discuss about the solution. Dear students, for me, if you solve a single question with the right method, then it works in many questions. But if you solve 100 questions and you are trying to match the answer, then it is not going to work at all. So it's my opinion, my request to you. I'm giving you a bit of suggestion that you solve a problem, apply the right concept, right? Now, dear student, solution I'm going to discuss with you are what is the solution? Now look here. Question is that this is east, this is west, north, south. Whenever there is a question based on the direction, first depict this figure. This will work a lot to you. You have to move from A to B, that is 500 kilometer apart, right? And the direction 30-degree due east, 30-degree east of north means 30-degree east of north means 30-degree towards east from north. 30-degree due east of north means 30-degree towards east from north, that is, this angle is 30-degree. Now, dear student, wind is blowing, velocity of wind is a 20 meter per second. Now, from the very basic concept of relative velocity, if the pilot will begin to steer its plane, sail its plane from A to B, then actually it will not reach B, it will reach somewhere here, right? So what you have to do, what pilot is to be suggested, that he has to travel from A to B. So actually he should steer in this direction. This is the velocity of plane with respect to wind, and then it is the velocity of wind, and then plane will reach. And who will observe that it has moved from A to B? Actually, the observer sitting here, then observer sitting here will observe that plane has moved from A to B. That is a velocity of plane with respect to ground. Okay? Dear students, what we have to do? Now, it is a velocity of, this velocity is given 150 meter per second. Now, dear students, take on this line, I am drawing a perpendicular like this, right? This is the wind, the component of velocity of wind along this, that is this angle is 30 degree. So we are talking about the velocity of wind away from this angle, right? Because this one is a perpendicular to this, and this is the VW. So VW has two rectangular component. One is this, and this one is a VW away from the angle, that is sine 30. And similarly, VPW has a one component, that is this velocity of wind has this component VW cos 30, and VPW has this component VPW cos alpha, whereas and this component is a velocity of plane with respect to wind also has the two component. This component adjacent to angle is a VPW cos alpha, whereas this component away from the angle VPW sin alpha. Because plane has to steer from A to B in this direction, there is no horizontal deflection. That is why this will be cancelled like this. VW sin 30 must will be equal to VPW sin alpha. So dear students, VW is perhaps 20 meter per second. Wind is blowing at velocity 20 meter per second. Sin 30 is a 1 by 2. That is equal to VPW is a 150 into sin alpha. And so it is a 10, 0, 0 will cancel. Sin alpha is equal to 1 by 15. This is, means the angle at which pilot has to steer his plane, that is alpha equal to sine inverse 1 upon root 15, not root 1 upon 15. What result you have got? That in order to steer the plane, in order to head the plane from A to B, the pilot has to steer his plane at an angle alpha from AB, that is alpha equals to sine inverse 1 upon 15. Now question is that how much time the plane will take in order to reach from A to B. Now dear students, the total velocities in the time is equal to distance over velocity. Distance is what? 500 kilometers they have to travel, divided by, this is into 10 to the power 3 because velocity is given into meter per second. Now total velocity in this direction is what? That is VW cos 30. VW is a what? Velocity of wind is a 20 cos 30 plus VPW. VPW is a 150 given in the question, 150, and that is cos alpha. Now dear student, sin alpha is given to you. You have to find out the cos alpha, no problem. Sin alpha is a, look here, sin, this is alpha, sin alpha equals to perpendicular upon hypotenuse, and this one will be, this is root 225 minus root 224, root 224, actually it is a 15, for me it's a 15, right? So dear student, T is equal to 500 into 10 raised to the power 3. Cos 30 is a root 3 by 2. This is 10 root 3. 10 into root 3 is a 1.7. So 10 multiplied by 1.73, that is 17.3 plus 150. Cos alpha is what? Cos alpha equal to base upon hypo. That is 15 upon 15. That is means approximately that works out to be 1. So write it only 150. So T is equal to 500 into 10 raised to the power 3. This is 167.3. Look here, I am solving here. T is equal to 500 into 10 raised to the power 3. This is 167 or 170. Consider this is 3. This is a 170. 0. So 3 or 3000 seconds divided by 60. This is 50 minutes approximately. Solution is 50 minutes approximately. I have considered, but it's at 2 because root 2 to 4 is close to root 2 to 5, so I have written it 15. This I was supposed to be solved, so I have considered it 170. 0 will cancel. 17 3s are 51, so it is a 3, and so it is 3000 seconds divided by 60. That works out to be 50 minutes. Mean in order to travel the plane from A to B, pilot will take 50 minutes. Okay, your flight would be duration of 50 minutes. Dear student, least but not last, I tried my best to let you to explain that whatever was going on the board. I'm very sure that you all are following my videos. If you think that my videos are going to work, then please like, share and subscribe, and must do put the bell icon so that you might be notified about my next video. Till then, goodbye. Meet you in next video. Bye.